A truck starts from rest and accelerates uniformly at 2 meter per second. Okay. At t is equal to 10 seconds, a stone is dropped by a person standing on the top of the truck, 6 meter above the ground. So first thing is we have a chance to draw. Let's do that. So we have a vehicle. We have a vehicle which starts with rest at time is equal to 0 second, and the other time is 10 second. By this time, of course, the vehicle would have gained some velocity. So it will start moving with certain velocity. So we don't know how much is that, but at the same time, you have a person standing and dropping a stone from a height of 6 meters. So this is 6 meters. And time is given. So we don't know the velocity. So we'll figure out the velocity, but we know that it is accelerating at 2 meter per second square. The question is, what is the velocity of the stone at 11 seconds and acceleration of stone at 11 seconds? So this is the question. Okay, try this. It's nothing fancy. It's the same thing that we have been doing. There's one bit of trickiness over here. Think about it. Okay, so first thing is, let's see what the vehicle, what is the status of the vehicle at 10 seconds, because from there is where we are looking at the stone's journey. So we are from the point of view of vehicle. So from point of view of vehicle. So let's start off. Okay, from the point of view of a vehicle, what we're looking at is, so we have V, the final velocity at 10 second is equal to U plus 80 is what we are using. So U is 0, acceleration is 2, and this is 10. This is basically 20 meter per second. So this is moving at a speed of 20 meter per second at 10 second. So how is this related to from point of view of the stone? So how is this related to the vehicle's movement? How is the stone's perspective related to the vehicle? Well, stone, when it's at 10 seconds, will have a velocity of 20 meter per second. Why? See, quite simple, commonsensical actually. If I have a vehicle which is moving at 20 meter per second, if a person is standing on that, since he's stable, obviously he has to be moving at 20 meter per second. If he's moving faster, means he'll go आगे and fall off. If he's moving slower, means he'll go पीछे and fall off. So he's stationary, he's standing over there. And the stone he's holding, it's also with him itself. So even that by default is moving at 10 meter per sec, 20 meter per second at 10th second. Okay, at 10th second. So this is the concept of how is that we're able to tell this? This is the concept of inertia. Okay, sorry, to as per inertia, when the person lets go of a stone at t is equal to 10 second, it will continue to move with 20 meter per second. Yeah, as per inertia. We have written this statement. I have given the reason as well. So this is nothing but your velocity along the x. Okay. So velocity along the x will remain 20 meter per second even at t is equal to 11. T is equal to 11 seconds, since they want us to figure out the, what is the question? Acceleration of the stone at t is equal to 1 second or 11 second now. They want us to, what are the velocity and acceleration of the stone at 11 second? Okay. At 11 second, right? Why is that? Because there is no horizontal acceleration. Okay, a lot of concept over here. It's quite simple actually. You don't need to technically, just for the sake of if it's an MCQ question, it's pretty much, there's no writing at all. It's just a 1 or 2 liner work and you're done. But this is, since this is an introductory topic per se, as of now we're still in that introduction stage, so I'm not cutting short the working, I'm writing everything. Now from the perspective of the stone, vertical along stone journey along the vertical. That's your y-axis basically. So it will accelerate downward with minus 10 meter per second square. If I consider up and right as positive, it's so. Since they're not asking, like, since they're not talking about when it hits the ground, what is the velocity and all of that, I can just deal with delta t, which is 11 minus 10, that is within 1 second. Right? Where is the object at? It starts with the initial velocity of 0 meter per second. Again, see, the vehicle is moving horizontally. So it will have horizontal velocity, it will not have vertical velocity. Okay, yes, that's a difference that you need to understand. It has horizontal velocity but not vertical velocity. Therefore, the vertical velocity will be minus 10 into 1. That is, Vy is minus 10 meter per second. Okay. So basically, the velocity at t is equal to 11 second will be V is 20 square plus of minus 10 square to the 0.5. So many meter per second, whatever that number is, that you guys can figure it out. So many meter per second. That's the velocity magnitude, that is. They're not asking for direction. Velocity, we'll find the direction also. So we have the stone, it's moving with 10 meter per second downward, and rightward is much more than 10. It's 20 meter per second. So your resulting velocity will be something like this. Say this is theta. Then the direction would be, actually heading should have been there. Direction will be tan theta, which is equal to Vy by Vx. Opposite is 10 by 20. So theta is equal to tan inverse of half. Whatever that value is, that you guys can calculate. This is with respect to or below horizontal. So we are measuring below horizontal. Finally, acceleration. This was your direction. The heading should have been here. Yeah, now it's proper. Therefore, now acceleration. The acceleration is what? Yes, there is only one acceleration, that is 10 j cap meter per second square. Sorry, minus 10 j cap meter per second square. Okay. So the object is not getting accelerated along the x-axis. So we just have y-axis and it is pointed downwards. So then we have 10 j cap meter per second square. Okay. So here we are looking at the concept of inertia. We got a glimpse of inertia. How is that? We had a person on a vehicle, standing on a vehicle, and once the vehicle gains certain velocity, then the person drops the stone. So when he drops the stone, what happens? The stone will not fall straight down. It will have certain velocity and it will fall in this manner, parabolic manner. Basically, the stone will take a parabolic manner. From a person standing on the ground, this is a person on the ground. For him, the stone would go in this manner. Okay, so all of this part you guys have studied how the parabola works and so on and so forth. So this has certain horizontal component and vertical component. So this question also you guys have done. You have seen the graph, you have seen it animated and so on and so forth. So you guys need to understand this. Combine this, all of this with the previous knowledge. So here we go into the next version of projectile motion. We are looking at the cause. What caused this horizontal movement? How did it gain this 20 meter per second is the question that we are trying to answer. Right? This comes from the concept of inertia in this case. So at 10 seconds, we have it moving at 20 meter per second because stone was part of the vehicle and the person. And the person and the vehicle are moving at 20 meter per second. So stone will also gain a speed of 20 meters per second along the horizontal because the vehicle is moving horizontally. There's no elevation there's no elevation of any sort. Horizontal surface. Right? So that is the entire concept. If not, it's the same set of problem as done previously in the previous chapters, that is.